What if everything we know about the origin of the universe is incomplete? For decades, modern cosmology has been built around the simple idea that the universe had begun with a Big Bang, a single moment where time, space, and energy came into existence. And from that moment, everything we see today slowly formed. Galaxies, stars, planets, and eventually us. But recently, something unexpected has happened. New observations are beginning to challenge that story. And they're forcing scientists to reconsider one of the most fundamental assumptions in physics, that the Big Bang was actually the beginning. The James Webb Space Telescope has been looking deeper into the universe than ever before, capturing light that has traveled for more than 13 billion years. In other words, it's looking back in time, to the earliest moments of cosmic history. And what it found doesn't quite make sense. Webb has detected galaxies that formed just a few 100 million years after the Big Bang. And that part was expected, but their size was not. These galaxies are massive, fully formed, containing billions of stars. Some of them are comparable in size to our own Milky Way. And according to our current models of cosmology, this should not be possible. There simply wasn't enough time. There wasn't enough matter. And the physics of the early universe doesn't allow structures to grow that fast. Yet, they exist. Astronomers have given them a nickname, universe breakers, because they seem to break the rules of what we thought governed reality. And this isn't the only problem. For years, scientists have been struggling with something called Hubble tension. It's basically a discrepancy in how fast the universe is expanding. When we calculate the expansion rate using theoretical models based on the early universe, we get one value. But when we measure it using real observations, supernovae, galaxies, gravitational lensing, we get a different value. And the difference is not small. It's significant enough to suggest that something in our understanding is missing. Now, with the latest data from Webb, this discrepancy appears even stronger. So the question becomes, what if our model of universe is incomplete? Some scientists are now exploring a radical possibility. What if our universe is not isolated? What if it's part of something larger? There are theoretical models suggesting that the early universe may have interacted with other regions of space, or even other universes. In these models, what we perceive as expansion could actually be the result of a much larger structure evolving. Instead of a single universe expanding outwards, we might be observing the merging or stretching of a much bigger cosmic system. And surprisingly, some of these models can actually help explain the mismatch in the expansion rate. But this is where things take even more unexpected turn. Because the idea that the universe may not have begun with a Big Bang is not new. Decades ago, physicist Roger Penrose proposed a theory that challenges the very concept of beginning. According to his model, the universe doesn't begin once, it cycles. This idea is known as conformal cyclic cosmology. In this framework, the universe expands over unimaginable timescales, trillions upon trillions of years. Eventually, all matter decays. Stars burn, black holes evaporate through a process known as Hawking radiation, and what remains is a universe filled with only radiation. No mass, no structure. And in that state, something remarkable happens. Because without mass, the concept of scale loses its meaning. And according to Penrose, this allows the infinitely large universe to become mathematically equivalent to an extremely small one. In other words, the end of one universe can become the beginning of another. Not through an explosion from nothing, but through a transformation, a transition. And if this idea is correct, then the Big Bang was not the beginning. It was simply the latest cycle. But Penrose goes even further. He claims we may already have evidence of this, hidden in the oldest light in the universe, the cosmic microwave background. This faint radiation is a snapshot of the universe when it was just 380,000 years old. When scientists analyzed this data, they found something quite unusual: circle patterns, regions that are slightly warmer than their surroundings. And Penrose calls these Hawking points. According to this theory, these are the remnants of supermassive black holes from a previous universe. As those black holes evaporated, they released energy. And that energy carried over into the next cosmic cycle, leaving behind subtle imprints that we can still detect today. Now, it's important to be clear. This idea is controversial, and many physicists argue that these patterns could simply be statistical fluctuations, basically random noise in the data. And that's a valid concern. Science moves forward by questioning ideas and not by accepting them blindly. But history has shown us something important. Many concepts that once seemed impossible eventually turned out to be real. Black holes themselves were once considered nothing more than mathematical curiosities, and today we have images of them. So where does that leave us? We have galaxies that form too early, an expansion rate we cannot fully explain, and possible signals from a universe before our own. Maybe the problem isn't the observations. Maybe the problem is the assumption that everything began once. Because if the universe is part of a cycle, then there was no true beginning, only transitions. And if that is true, then this universe is not the first, and it won't be the last. If you like these sort of videos, please subscribe to this channel. I'll be releasing this sort of content once or twice a week, and until then, keep thinking.